Typhoon Yolanda left the country with a devastating situation, specifically in Visayas region. One of their biggest problem is the lack of clean water source. Out of desperation, residents just drink any water source they know, thus resulting in sickness and other diseases. This type of situation can be reduced using a system that can provide an alternative water supply, one of which is a modified rainwater harvesting system. This is our study entitled Rainwater Harvester with Electric Water Purifier using Ceramic Filtration and Ultraviolet Light with pH Sensor by Alangkao, Bagul, Bulfa, and Clavio of BS COI 51. The similarities and differences between our system versus IRHS or Innovative Rainwater Harvesting System by Dr. Antonio F. Mateo. Venn diagram of our system and IRHS. Our system, it has conductivity sensor, pH sensor, carbon filter, odor and taste filters, and UV light. IRHS system, it has second screen in the first rainwater tanks, rainwash water diverter, mineral stones as pH improver, and filter with antipathogen. And the similarities of both systems, they both have screen before the downspout and ceramic filters. Figure shows the block diagram and scope of the system. Inputs of the system are the rainwater conductivity and pH level. Conductivity is tested through the conductivity sensor, while pH is tested through the pH sensor. The sensors send the signal to Arduino. The Arduino controls the solenoid valves, which controls the gates of the water pipe. The water will be disposed and be classified as wastewater if it did not pass the test. Qualifiers of the test and are classified as harvested water will proceed to the treatment process or be used for non-potable purposes. For the treatment stage, harvested water will undergo ceramic filtration. Following the filtration is the purification using the UV light. After these treatment processes, potable water will be achieved. Modifications. Old versus new system. Conductivity sensor. The old uses metal probes, while new uses stainless probes. The old doesn't have a pH sensor. The new system has pH sensor. Ceramic filter. The old has one. The new has two filters. UV indicator. The old system, none. The new system has an indicator. Float for the storage. The new system installed one. Old system, none. And the flow rate. Old system is 0.31 liters per minute. New system, 3 liters per minute. Design changes. For third floor, piping design in the second and third drum was modified, and a manual valve was placed between first drum and second drum. For the second floor, the filter was relocated on the side of the building with an additional ceramic filter. Also, the drum for the filtered water was moved up. It was originally placed on the ground floor. For the ground floor, on the new system, only the filters and UV chamber remained and was placed inside a wooden cabinet. The conclusion answers the statement of the problem of the study. First problem is how to filter the wind-blown dirt, leaves, fecal droppings, and other solid materials contaminated in water during first flush. It is by blocking the solid materials using strainer and clothing that was placed on the downspout. Problem number 2. How will the rainwater be dispensed when it is proved to be unqualified for water treatment process? The water will be dispensed using the solenoid valves controlled by the Arduino. Last problem. How to assess the acidity of the harvested rainwater? It is by using a pH sensor. The circuitry of the study is composed of water conductivity tester, pH tester, and solenoid valve. The power supply circuit manages the distribution of the power of the circuits and Arduino, Water conductivity tester and the pH tester manage the testing of the rainwater that will pass through the water pipes, and the signal from the circuit will be sent in Arduino. The solenoid valve circuit controls the two solenoid valves that act as gates for the separation of the dirty and clean rainwater. The UV lamp indicator checks if the UV light is on. The power supply circuit supplies all the power needed in the entire system.